Hello students, welcome to experiencetutor.com. Today's lesson is class 11th IIT Mathematics complex number part 5.
Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
De Moivre's theorem. According to this theorem, if n is any integer, then if n is any integer, then cos theta plus I sin theta is equal to the power n is equal to cos n theta plus I sin n theta. Similarly, we can write in the binomial form, say if z is equal to r cos theta plus I sin theta, then and n is a positive integer, then we can write z 1 upon n is equal to r 1 upon n cos 2k pi plus theta upon n plus I sin theta sin 2k pi plus theta upon n. K is equal to 0, 1, 2, in this way it can go up to n minus 1. Now we'll study logarithm of a complex number. So to express log e base x plus iy in the form of a plus ib. So here we are trying to express log e base x plus iy in the form of a plus ib. We have we have x plus we have z is equal to x plus iy is equal to r cos theta plus I sin theta, where r is equal to modulus of z, which is equal to under root x square plus y square, and theta is equal to argument of z z is equal to tan inverse y upon x is equal to r e to the power I theta into 1 is equal to r e to the power I theta into e to the power I 2k pi. We can write 1 as this, e to the power I 2k pi. Why we have written this? The explanation is given here. E to the power I 2k pi is equal to cos 2k pi plus I sin 2k pi. Is equal to 1 plus I 0, which is equal to I dot 0, which is equal to 1. Therefore, instead of 1, we can write e to the power I 2k pi. Therefore, z is equal to, we can write r e to the power 2k pi plus theta k is an integer where k is an integer. Where k is an integer. Now, if we put logs in both the side, then we'll get log e base z is equal to log e base r e to the power 2k pi e to the power 2k pi plus theta. theta is equal to log e base r plus log e base I 2k pi I 2k pi plus theta is equal to log e base r we can write this as log modulus z and and we can write the next step as yeah. So we can write and log e to the power e is equal to uh, I 2k pi 2k pi now we can write log e to the power r as log modulus z plus I 2k pi plus theta is equal to so this is the expression for log e to the power z. Now here it is divided as a real and imaginary part. So we can, which implies that we can write as log e z is equal to log x plus iy is equal to half log x square plus y square plus I 2k pi plus tan inverse y upon x, which is the required form, where the first part is real and the second part is imaginary. Now we have to prove this expression. So let z is equal to x plus I y. Therefore, therefore z conjugate of z is equal to x minus I y, and modulus of z is equal to under root x square plus y square. Now tan I log n z modulus upon z is equal to tan bracket I log e modulus of z e e minus I argument of z upon modulus of z e I argument of z to the power n into z is equal to modulus of z e to the power I argument of z, z, which is equal to 10 I log e base e to the power minus I minus 2I argument of z, argument of z, bracket closed, denominator went to numerator, so it is minus 2 power, the index is power, minus 2 I argument of z. Nothing else, very simple. Now this expression can be simplified by 10 minus 2 I square argument of z log e base e is equal to 10 to theta, where theta is equal to argument of z, z is equal to 10 inverse y by x. Therefore, we can write using the trigonometry we can write 10 to theta is equal to 2 tan theta upon 1 minus tan square theta, which is equal to 2 y by x upon 1 minus y square by x square is equal to 2xy upon x square minus y square, which is equal to 2 into real part of z into imaginary part of z upon real part square real part of z square minus imaginary part of z square. Now we'll see square root of a complex number. So let under root a plus ib is equal to x plus minus I y. Squaring both the sides, we can get a plus minus b. Squaring both the sides, we can get a plus minus ib is equal to square whole square of a plus x plus minus iy is equal to x square plus I square y square plus minus 2I x y is equal to x square minus y square plus minus I 2x y, which implies that x square minus y square is equal to a, on equating the real and imaginary parts, and 2xy is equal to b. Therefore, x square plus y square whole square is equal to, we can write x square minus y square whole square plus 4x square y square is equal to a square plus b square. Therefore, we can write x square plus y square is equal to under root of a square plus b square, and x square minus y square is equal to a. So let this is equation 1 and this is equation 2. On addition of 1 and 2, so if we do 1 plus 2, then we'll get 2x square is equal to under root a square plus b square plus a, which implies that x is equal to plus minus under root a square plus b square plus a upon 2 to the power half. if we subtract equation 1 minus equation 2, then we'll get 2y square is equal to under root a square plus b square minus a, which implies that y is equal to plus minus bracket and under root a square plus b square minus a upon 2 to the power 1 upon 2. Hence, under root a plus ib is equal to under root a square plus b square plus a upon 2 to the power half plus minus I under root a square plus b square upon minus a upon 2 to the power half, bracket closed, which implies that under root z is equal to plus minus modulus of z plus real part of z upon 2 to the power half plus iota modulus of z minus real part of z upon 2 to the power half. We take sign of imaginary part of the square root as positive or negative according to the imaginary part of z is greater than 0 or equal less than 0. We can use De Moivre's theorem to find out the square root of complex number, and the concept can be generated to find nth root also. The above mentioned is not sufficient. The above method is not sufficient for finding nth root. So we observe that we observe that x plus I y is equal to r cos theta plus I r sin theta is equal to r common bracket 2 k pi plus theta plus I sin 2k pi theta plus theta bracket closed is equal to x plus I y to the power 1 upon n is equal to r to the power 1 upon n cos 2k pi plus theta plus I sin 2k pi plus theta bracket 1 upon n to the power. So we can write this now. The equation which will come is r 1 to the power n 1 upon n cos 2k pi plus theta upon n plus I sin 2k pi plus theta upon n to the power bracket closed is where k is equal to 0 1 2 3 dot up to n minus 1, which gives the n and nth root of complex number x plus I y. Now we'll try to find out cube root of unity. So we know that one is equal to cos 0 plus I sin 0. Therefore we can write the same as cos 2 k pi plus I sin 2k pi. where where k is equal to any integer. Now if we put root on both the sides or power half on both the sides, then we'll get 1 to the power 1 by 3, sorry, cube root both the side, then we'll get 1 up to the power 1 by 3 cos 2k pi plus I sin 2k pi to the power 1 by 3 is equal to cos 2k pi upon 3 plus I sin 2k pi upon 3, where k is equal to 0, 1, 2. Therefore cube root of 1 or unity is equal to cos 0 plus I sin 0 cos 2 pi by 3 plus I sin 2 pi by 3 and cos 4 pi by 3 plus I sin 4 pi by 3, that is 1 alpha square, where alpha is equal to cos 2 pi by 3 plus I sine 2 pi by 3 is equal to minus half plus I root 3 by 2. Here we have observed that there are three cube roots of unity given by one, then minus half plus I root 3 by 2, and third one is minus half minus I root 3 by 2, out of which one is purely real, other two are conjugate complex number such that sum of cube roots of uh, unity is equal to 1 plus alpha square is equal to 1 plus 1 minus, it should be minus, so alpha is minus half plus I root 3 by 2, again minus half minus I root 3 by 2 is equal to 0. The product of cube roots of unity is 1 into alpha square is equal to alpha cube. Is equal to 1. Now we'll learn about the few of the properties. So first property is, if 1 alpha and alpha square are cube root of unity, 1 alpha and alpha square are the cube root of unity, then are cube roots of unity, then we can write a plus b alpha plus c alpha square is equal to 0, implies that, so a is equal to b, a is equal to b is equal to c, provided a, b, c are real. Provided A, B and C are real. Now the second rule, second property, one plus alpha square, or 1 plus alpha to the power n plus alpha to the power 2n is equal to 3 or 0. 3 or 0 according to the value of n is multiple of 3 or not. So accordingly, as n is a multiple of 3, of 3 or not. Third property, alpha 3m plus alpha 3m plus 1 plus alpha 3m plus 2 is equal to 0. Mn here, it will be better if we put 3n m and this one as p, 3p plus 2 will be 0 if m, n and p are natural number. The next property is 1 alpha and alpha square when represented on argand plane lie on the vertices of the origin. One vertex lies on the positive real axis. Fifth property is if p is a p be the cube root of a number, then the other cube root are p alpha and p alpha square. So this one is important. So if p is the cube root of any number, say p is the cube root of any number, is p is equal to cube root of a number, then other cube roots are other cube roots are other cube roots are p alpha and p alpha square. Now we'll try to understand the nth root of unity. Nth roots of unity. We have 1 is equal to cos 0 plus I sin 0 is equal to cos 2k pi plus I sin 2k pi. K is an integer. Therefore, we can write 1 to the power 1 by n is equal to cos 2k pi plus sin 2k pi to the power 1 upon n, which is equal to e to the power I 2k pi upon n. Here k is equal to 0, 1, 2, dot 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 n minus 1. Therefore, we can write 1 alpha q alpha square alpha q and dot 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 till alpha to the power n minus 1, where alpha is equal to e to the power 2k pi I to 2k pi upon n is equal to cos 2 pi upon n plus I sin 2 pi upon n. Now we'll see a few of the properties. First property is nth root of unity, which forms a geometric progression with the first term, and common ratio is 1 and alpha respectively. Second property is sum of the nth root, say 1 plus alpha square dot 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 alpha to the power n is equal to alpha to the power n minus 1 upon alpha minus 1. is equal to 0. If n is not equal to 1, if n is equal to 1, the sum is 1. The product of n and nth root of unity is, that means 1 into alpha square plus into alpha q dot 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 to the power alpha n minus 1 gives minus 1 to the power n minus 1. The fourth property is the n and nth root of unity located in the vertices of a regular polygon of n side inscribed in a unit circle, having center at origin and one vertex being on positive real axis.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.